is Sir Phil again from Sir Phil's channel, and if you're new in this channel, please don't forget to subscribe or click the subscribe button, and of course click the notification bell to keep updated on my latest video in this channel. So today we're going to enter the week 2 and week 3 for the most essential learning competencies for Mathematics 9, starting with the first lesson, the nature of the roots of a quadratic equation using the discriminant. With this lesson, we'll be able to determine the nature of the roots of quadratic equation. Also, we're going to recall the concept of solving quadratic equation using the quadratic formula, because this lesson, especially the new word here, which is the discriminant, is related on the quadratic formula. So let us have first some review examples of solving quadratic equation using the quadratic formula. So let's start. So from our discussion from the previous video, the quadratic formula, the solution for a quadratic equation of the form ax squared plus bx plus c with a is not equal to 0 are given by the formula x equal to negative b plus and minus square root of b squared minus 4ac all over 2a. So we're just going to use this in solving the following examples of quadratic equation. So we have here the first example. We're asked to solve x squared minus 3x minus 28 equal to 0. So by that, we get the values of a, b, and c, which are positive 1, negative 3, and negative 8 respectively from the given quadratic equation. And for that, we're just going to substitute the given values to the formula. So we have negative quantity negative 3 plus and minus square root of negative 3 quantity squared minus 4 times 1 times negative 28 all over 2 times 1. So all we did is that we substitute a, b, and c, the values of those numbers from on the formula. So by simplification, we have here x equal to positive 3 plus and minus square root of 9 plus 112 all over 2. So we're just going to simplify it again. Then we have 3 plus or minus square root of the sum of 9 and 112, which is 121 all over 2. So by simplification, we get the square root of 121. We have x equal to plus 3 plus and minus 11 all over 2. And then we're going to solve these separately. The first one using the addition and then the other one using the subtraction. So we have x equal to 3 plus 11 all over 2. And then 3 plus 11 is 14 divided by 2, which is equal to positive 7. And then the other one using the negative or subtraction, we have 3 minus 11 divided by 2. And 3 minus 11 is equivalent to negative 8 divided by 2, so that is equal to negative 4. So we have here two unequal real and rational numbers. 7 and negative 4 are unequal. They are both real and rational. So later, we're going to determine it using the discriminant. No? Let's have another example. So we have x squared minus 8x plus 16 equal to 0. So following the process of solving quadratic equation, using the quadratic formula, we have the values of a, b, and c, which is 1, negative 8, and positive 16 respectively. So all we have to do is to substitute to the formula. So you have this. Then by simplification, we'll have positive 8 plus and minus square root of 64 minus 64 all over 2. By that, we have now x equal to 8 plus and minus square root of 0. That's the difference of 64 and 64 all over 2. So by simplification, the square root of 0 is 0. So that is 8 plus and minus 0 all over 2. So as you can see, this will not affect the equation. So we will have 8 and 2 only. So 8 divided by 2 is equal to 4. So as you can see, we have only one solution here. Since this is a quadratic equation, we still have two solutions, but this time we have two equal real and rational solutions. So from the first example, we have two unequal real and rational. So this time we have two equal real and rational. So it depends on the given quadratic equation. So let's have the third one. We are given 3x squared minus 5x plus 9 equal to 0. So let us have now the solution using the quadratic formula. So again, we get the values of a, b, and c. We have positive 3, negative 5, and positive 9 respectively. And all we have to do is to substitute them to the formula. And then we have this. And then we have to simplify it. We have now positive 5 plus and minus square root of 25 minus 128 all over 6. So you can see a pattern here with the number inside the radical or the square root. So we have here 5 plus or minus square root of negative 83 all over 6. So we have here a negative number inside the parentheses. That's why it became x equal to 5 plus and minus the imaginary sign or I square root of 83 all over 6. So we make the number inside the square root positive by putting imaginary here, because this is now an imaginary number since we have a negative number inside the radical or a square root. So we'll have the two solutions here, one using the addition and then the other one using the subtraction. So what type of solution is this? So from our discussion from the previous video, these are imaginary roots or solution, are simply a complex number solution. So there are two unequal imaginary roots here, or two unequal complex roots. Or we can also say that it has no real roots. Okay, so please observe what is happening on solutions of each example here, because we're going to apply it later in the discussion of the discriminant. So let's now proceed with the last example. We are given 2x squared minus 8x plus 1 equal to 0. So all we have to do is to again get the values of a, b, and c. We have positive 2, negative 8, and positive 1 respectively. And after that, we substitute it to the formula, to the quadratic formula. And then we will have this simplified form. We have x equal to 8 plus and minus square root of 64 minus 8 all over 4. So we have here now 8 plus and minus square root of 56 all over 4, and then we have to simplify 56 here since this is not a perfect square. And then we have x here equal to 8 plus and minus, and then we factor 56, which is one of the factor is a perfect square. So that is 4 times 14, in which 4 here is a perfect square all over 4. And we simplify, we have x equal to 8 plus and minus the square root of 4 is 2, square root of 14 all over 4. And then we can accept now this answer, but we can still simplify this by factoring out 2 here from the numerator. We have 2 quantity 4 plus and minus this time square root of 14 quantity. And then that's why, because it is because we factor out 2 all over 4. And then we can simplify 2 here outside on the numerator and the denominator, which is 4. We can cancel now this 2, and then this 4 will become 2. And then the remaining equation is now x equal to 4 plus and minus the square root of 14 all over 2. So the solution is an irrational solution or irrational roots. So we have here 2 unequal irrational roots. So we have four different solutions. So we just recall this quadratic formula to with four different types of quadratic formula with also four different types of solutions. So let us now summarize that. Note that these four examples demonstrate a pattern. No? You can see a pattern there that is useful in determining the nature of the root of a quadratic equation. So in the quadratic formula, in the expression under the radical sign or the square root, we have b squared minus 4ac. If you can still remember, it is called the discriminant. So the discriminant tells the nature of the roots of a quadratic equation. So there is no need for us to actually solve the quadratic equation for us to determine its nature. Just by the use of the discriminant, which is given by b squared minus 4ac, we can easily determine the nature of the roots of a given quadratic equation. So I have here the summary of our discussion on the discriminant. So again, the discriminant is given by b squared minus 4ac, in which this will tell us about the nature of the roots of a quadratic equations. I have here the summary using a table. We have the equation from example 1 to 4, and then we have here the value of the discriminant, and then the roots that we got from the solving, just to confirm if our answer is true. And then the nature of the roots. Let's start with the first example, no? Using the discriminant, again, by the use of the values of a, b, and c. So we have negative 3 squared minus 4 times 1 times negative 8. As you can, if you can remember the value inside the radical from our example a while ago is 121, in which 121 is a perfect square. So here, the discriminant is positive and a perfect square. So if the discriminant is positive and a perfect square, the nature of roots is are two unequal real roots or rational roots. We can say two unequal real roots or two unequal rational roots, and that is 7 and negative 4 from our solving. So but we don't need to do this since we're just asked about the nature of the root. So if we're just asked about the nature of the roots, we're just going to use the discriminant. Okay, for the second example, we have x squared minus 8x plus 16 equal to 0. Again, the discriminant is given by b squared minus 4ac. So we substitute negative 8 for b, minus 4, and then positive 1 for a, and then positive 16 for c, equal to 0. So here, that is 64 minus 64 from our solution a while ago. So the discriminant here is equal to 0. So if the discriminant is equal to 0, the nature of the roots are two equal real root or rational roots. Okay, so that's it. Then we have here 3x squared minus 5x plus 9 equal to 0. So we have b squared minus 4ac for the discriminant. Substitute negative 5 for b, minus 4 from the formula, and then 3 for a, and then 9 for c. And then we will get negative 83. So the discriminant is equal to negative number. So if the discriminant is negative, the nature of the roots are two unequal imaginary or complex roots, or as I said before, we can also say that this quadratic equation has no real roots. And finally, we have 2x squared minus 8x plus 1 equal to 0. So again, we have the discriminant b squared minus 4ac. So by substituting the values of a, b, and c, negative 8 for b, minus 4, and then 2 for A, and then 1 for C. And then we have here 64 minus 8. So 64 minus 8 is 56, which is a positive number, but this number is not a perfect square. So automatically, the nature of the roots are two unequal irrational roots or irrational solutions. So let us again summarize. So if the discriminant is positive and a perfect square, the nature of the roots are two unequal real roots or rational roots. If the value of the discriminant is 0, we have two equal real roots or rational roots. And then if the value of the discriminant is negative number, so the nature of the roots are two unequal imaginary or complex roots. If the value of the discriminant is positive but not a perfect square, the nature of the roots are two unequal irrational roots or solution. So let us have example for that. So find the value of the discriminant of each equation and then describe the nature of its root. So we have here the given 2x squared plus x minus 3 equal to 0. So we are just asked to find its discriminant and then describe the roots. So let's go back from our summary. This is what we're going to determine. The value of the roots and then the nature of the roots. So the nature of the roots depends on the value of the discriminant. Okay, let's proceed. So again, we get the values of a, b, and c, positive 2, positive 1, and negative 3 respectively. Substitute it from the discriminant b squared minus 4ac. So we have 1 squared for b minus 4, 2 for a, times negative 3 for c. By simplification, we have 1 squared 1. Negative 4 times 2 times negative 3 is positive 24. So 1 plus 24 is 25. So as you can see, this is a perfect square, and a positive number. So what do you think is the nature of the root? The nature of the roots of this quadratic equation, since this is positive and a perfect square, so therefore we have two real roots and they are rational. At the same time, they are unequal two real roots or unequal two rational roots. Let's have another. Find the value of the discriminant of each equation and then describe the nature of its root. So we have here x squared plus 8 equal to 0. So we have a missing term here. So a here is 1, b is 0 since the linear term is missing, and then c is equal to 8, which is our constant term. So substitute to the discriminant b squared minus 4ac. We have 0 squared for b minus 4 times 1 for a times 8 for c. Simplify, we have 0 minus 32, and that's why we have negative 32. So the value of the discriminant is negative. So x squared plus 8 equals to 0 has two imaginary complex roots. Imaginary or complex roots, or simply we can say that this quadratic equation has no real roots. You can always come back here and review the video so that you can have more practice in this lesson. This is the importance of the discriminant. No, we can actually describe the nature of the roots of the given quadratic equation without solving the quadratic equation, and that is our discriminant. Thank you for watching. Again, we have our week 2 and week 3 of the most essential learning competencies in mathematics 9. See you again next week for the next lesson for week 2 and week 3 of the MELCs Mathematics 9. So again, I will leave you that mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. So by doing mathematics, we can practice deeper on how to understand things in mathematics. So we do mathematics, we understand mathematics because mathematics is all about understanding, and it will help us in understanding more about the universe, our surroundings. Okay, so this is Sir Phil from Sir Phil's channel. Thank you for watching. The consecutive lessons for the most essential learning competencies in Mathematics 9. See you again on my next video. Click subscribe and the notification bell to be updated on my latest video. Thank you very much for watching. Again, this is Sir Phil in Sir Phil's channel.